Here, we present our work, Timestamp Supervised Action Segmentation with Graph Convolutional Networks. Human activity video datasets can provide valuable insights for guiding, monitoring, and standardizing the activities being performed. However, training deep neural networks for fully supervised action segmentation requires costly, frame-wise labels. Our approach elevates this problem by using timestamps, that is, labeling a single frame from each action segment as shown by the color-coded segmentation band at the bottom of the video. We can see that the total number of frames in our sample video for a fully supervised approach is 810, and the number of frames for a timestamp-based approach is only 23. This constitutes a 97% reduction in the need for labeled frames. Our approach is divided into two stages, the initialization stage and the refinement stage. First, we'll look at the initialization stage. We start off with a video that is passed to a segmentation model. In our case, we use MSTCN as a segmentation model. Our segmentation model is then trained using sparse timestamps as the ground truth. The initialization stage helps us to generate better frame-wise features than compared to the same segmentation model with random initialization. After the initialization stage, we move to the refinement stage. Here, we aim to use the frame-wise features that were learned by the last layer of the segmentation model during the initialization stage as input to the GCN. For each video, we construct a weighted graph for the GCN. Within each graph, all frames along with their features are considered nodes. Finally, we assume a temporal window within which we connect all neighboring nodes with weighted edges. We then train the GCN on sparse timestamp labels to predict on all frames to get dense frame-wise labels. After generating these dense frame-wise labels, we then switch to our segmentation model. This time, we use the dense frame-wise labels that were learned by the GCN as the ground truth to the segmentation model. This completes a single iteration of the refinement stage. Our approach outperforms the previous state-of-the-art by 5%, transcript supervision by 13%, and set supervision by 30%. To conclude, we propose a novel method for timestamp supervised activity segmentation which utilizes a graph convolutional network for generating dense frame-wise labels from sparse timestamp labels. The graph convolutional network is learned in an end-to-end fashion to use not only frame features but also connections between neighboring frames. Moreover, we present a framework for alternating learning of both the segmentation model and the graph convolutional model. We also show that our method is superior to other weakly supervised approaches while performing on par with or better than the state-of-the-art in timestamp supervised activity segmentation.